So I'm doing two talks because, well, I was asked to. So the first is on a native client implementation of Forth. And the motivation is that I actually work on native client in my day job, and it allows it's a feature in Google Chrome that allows machine code to run in the browser. Forth excels at bootstrapping new environments. And I've tried other Forths on top of JavaScript, and they were slow, and that was not fun. So, so what's Native Client? Native Client is a static verification sandbox. What that means is that you're able to enforce that your code doesn't do malicious things by verifying at the point that you load it that it meets certain constraints. It supports multiple threads, so multiple cores. It runs in the browser. Currently, you can use it in the stable version of Chrome, the normal version that you may have installed, with the one constraint that Native Client is only available if you have installed something called a web app, which is really just, depending on the mode you do it, is just a glorified bookmark that sort of grants authorization to a particular page. There are resource restrictions that are similar to JavaScript. So the idea is that the security model around JavaScript is sort of thought to be reasonably well understood, and so the hope is that native client isn't sort of opening up more than JavaScript does. Depending on, benchmarks are tricky, but the belief is that the static sandbox constraints add an overhead of about 15%. One of the motivations here is Google is pursuing a concept they call in Chrome OS, which is a system a dedicated computer that runs nothing but a web browser. And on that system, the only way you would be able to run native code is through native client. There's different versions of the sandbox for different architectures because the way that you need to structure this to be safe is different. And there is a notion of a sort of a portability layer, but at this point you have to produce code for each of the architectures. And in practice, there is an ARM sandbox, but it's not really deployed in any form that you could actively use. So the way the sandboxing works, the key trick to it is the idea that you enforce that code is produced in some chunk size, and for most of the sandboxes, they happen to have settled on a 32-byte chunk, and you make the constraint that every 32-byte chunk you need to be able to straight line disassemble it. And that all jumps and calls have to enter that 32-byte chunk. So you can't jump to the middle of a 32-byte block. There are a variety of different techniques for restricting where you can write to. The idea is, of course, you can't at least directly write to overwrite your code. And then all of the I/O you have to. There are these trampolines that are special blocks that you can. 32-byte blocks that get you out of the sandbox that don't have to meet the same set of constraints. What happens then is when you've got a chunk of machine code to load, it gets validated when it's loaded, and then it's sort of let to go run free. Some of the trampoline calls let you do dynamic insertion of code, and so you can set up in a separate buffer some chunk of machine code that you want to load, and then drop it into place. It will be dropped into place by the system after it's been validated, so you can do dynamic things. So I actually I've had sort of, this is actually my second go at this. I actually had a ColorForth-based implementation that was based on an early NACL prototype, and then they changed the way the I/O was plumbed on me, and all sorts of fun stuff. And so due to constraints of time and also because my old ColorForth-based implementation was x86-32 only, which doesn't work on everybody's browser, I went back to doing an indirect threaded kernel that was done done in C, so I could take advantage of the versions of GCC that they have that will produce code that meets these constraints. So it's very traditional looking sort of indirect threaded kernel done in C. My hope is to get back to generating my own code and to maybe do subroutine threaded stuff on top of that. And this gets me sort of in the sandbox and free to do dynamic calls. There's a C kernel that's about 750 lines, and then so NativeClient's communication model, the only thing you have that you can really talk to is a bunch of system calls, and then you can also communicate with JavaScript. And the simplest thing to do to get things going was to have sort of a JavaScript bridge to the outside. I wanted to be able to have some kind of storage that's associated with your account. So there's some plumbing in JavaScript to let you use Google accounts for storage for that. And I do hope to get back to the color-forth experiment I had been engaged in, but this at the time seemed expedient to not have to learn. One of the tricks with bootstrapping the old color-forth one was that I had to be generating code that met the sandboxing constraints, and that's just an extra wrinkle that I didn't want to deal with. So this is sort of what the system looks like. You've got, in the browser, you're looking at a certain web page. It's running a JavaScript shim that communicates using this API called Peaky API to the NACL module that's running in the sandbox. And then there's HTTP requests that are used to read and write to the data server so you can load and save stuff. I'm going to demo it in a second, but I mean, so places I hope to go with it. Right now, its only real communication to the outside is through JavaScript, so it's sort of basically a raw terminal. But there's all kinds of bindings for NACL that would let you, directly talk to the graphics card or to a pixel buffer, that sort of thing. And I'm even bridging like web requests over to the JavaScript, whereas you can actually do that directly in the sandbox. And I'd like to, get back to generating actual native code for it. Right now, you simply, I mean, you could do the process of bootstrapping to actually do code words, but right now everything is just indirect threaded. And yeah, oh, I actually did that with ProPH extension. Anyways, let's go and actually look at the thing. So it works as a web app, which the way this works is that when you're in the latest version of Chrome, there's a web store, and if you were to, for instance, search for forth, curiously, it doesn't show up with NACL forth. I just got to talk to the indexing folks. Come on. And you would be able to install it, and it is added into the browser. This is actually, I originally did it as a what's called a hosted app, where it's just a glorified bookmark. But there are certain advantages to doing it as a packaged app, where Google sort of hosts the app for you. One of which is that will put it in a mode where the browser will keep a cached copy. So if you're offline, you can actually use it. So you click on it, and it boots. And what it's doing on startup, and there's a real forth under here. What it's actually doing on startup is there's a core kernel in C, and then there's a small amount of code in a startup file that gets loaded. In fact, I can load that. Got a very, very crude editor going here, but it's still a work in progress. So there's some additional plumbing in here to the start of me getting the editor implemented and this sort of thing. But it's at least a functional system, and you're there actually running in your particular architecture. You can define a word and something like that. But yeah, it's interestingly, I really do want to get rid of the JavaScript shim, because it's it's not too bad the response time here, but actually even just little experiments with the editor, it's surprising. JavaScript slowness gets in the way, so I want to really get back to the place where I'm writing to a frame buffer. But that's where that's at. Questions? What? So yes, you can. So right now the saving and loading is relatively crude. I have a load and a save word. Load will just load a file off of the server. That's tied to your account. You have to be logged in up in the corner for that to work. Save is a little peculiar at the moment. It takes a string, a counted string, followed by a line count, assuming 80 column lines of text that it will load out of the editor's range. So you have to tell it what the length is. I plan to clean that all up fairly soon to give you something where it does something a little more sane, but that's where it's at the moment. All right. Let me move on to the other topic. Oh, and I should mention in reference to interestingly, some of John's tricks with some C90 features that I was unaware of might have made this cleaner. What I actually did with the C implementation, I also have a bunch of macros to set up the dictionary. However, not knowing about some of those C90 features, I ended up doing a dictionary that uses null terminated strings, for instance, for the names, but I'm able to use a GCC feature called computed gotos. These are kind of peculiar, but let's see where's the actual dictionary? I can't do it on this screen where I can actually see it. Okay, that's the macros, and where's the actual dictionary? Oh, and then so here's the actual, in the midst of using the macros to define the dictionary. And then these are actually referencing labels down here that actually have the implementation of the individual words. So that's that. Anyhow, so the other fun one. This is also a bit of a rehash from folks have seen, but so I have this notion of a fourth haiku. And the motivation here is that brevity is the soul of wit, and that constraints improve art, and that you can get fairly terse equations that produce things that at least to humans look interesting. Perhaps that's just our peculiar take on the matter. But and so I've lifted the word haiku, which is a very specific cultural thing, but it's the notion of a seven syllable poem. And what I mean by a fourth haiku, or at least how I've chosen to define it, is a 17-word haiku that defines an image in a coordinate space from 0 to 1 in X and Y. And there's 3 stanzas for red, green, and blue. And there's a very limited vocabulary. I ended up using floating points, the assumption of floating point cells. That's not, that's arguably just there are some interesting things that fall out of that, but that's not absolutely essential. So these are the current words that I settled on. They're pretty typical. The interesting ones are X and Y are the X and Y coordinate at the current location you're rendering. So the haiku is run once for each pixel. So it's sort of capable of being massively parallel. And there's a time parameter, which I can talk about in a moment with animation. Most of them are sort of interesting transcendentals, and then Z plus and Z times are complex add and multiply. That proves to be kind of handy. Random's a little frivolous. It's not really random. They've got various sort of deterministic kinds of random that are interesting to use. So very basic example is a solid color is just 3 numbers, the red, green, and blue. I ended up having the convention that whatever's left in the data stack will get sort of 0 padded, so that you start with red. That proved more intuitive to me, although it has a bunch of weird quirks. So for instance, simple one, a gradient is just x, and then the green and the blue are like that. You can do more complex things. You could define so here you've got x and y giving you a gradient in red and green, and then the blue is having a parabola that's with a bound around it of 0.1. And this is sort of, I wanted to have this be something that people could sort of, throw things out there. So I've got a web app up that does it. And the original implementation was using a JavaScript. So it was all done in JavaScript. So you take the fourth code, and then it's sort of statically converted to JavaScript, and then it draws to a feature called Canvas. Then, of course, after having stationary haikus, the next thing I wanted was animation. And the performance just isn't there for anything sizably interesting. So I have a further conversion step that goes from JavaScript to Webgl, which is an emerging standard a number of browsers support now. It's basically a variant of C that's used to express what's called a fragment shader that lets you use the GPU and is actually rendered massively parallel. So what happens is you have something like, what's going on underneath is you have a fourth expression. It gets converted to some rather unpretty JavaScript code that it actually isn't too bad, the performance with a lot of modern JavaScript engines. They're compiling to machine code on the fly, and they do a bunch of optimizations. And something as grisly as that doesn't actually end up being. Oh, I just literally copied and pasted this out from debug output. The Go is so that there's I'm doing this inside of an eval, so it's actually so that there's something to eval there and get back out. And then when it gets converted to WebGL, there's sort of a direct translation I can do that turns it into some even uglier WebGL C code, which is horrific. And there's all kinds of lovely embellishments you can do. You can introduce animation by adding it. I've got T, which is I've defined as the second since midnight local time. If you provide a fourth value in the data stack, it is treated as an alpha component, and this lets you carve out transparency. And so I've been able to use this. It's actually very convenient for producing icons. For instance, the Knuckle fourth icon was made using Haiku. And audio was actually a bit tricky. And the prior presentation, I did some attempts at doing raw audio, which was terrible. I mean, it's amazing the difference between when you produce images. It's very easy to produce something colorful and aesthetic, but audio, it needs to be very constrained to what we find aesthetic. People gave me some feedback, and I now use a pentatonic scale that's based on the images. It's a little bit better, as you'll see. I'm not. That's a bit of a work in progress, but anyways, let's. So.
I wanted to mention that this was a big hit at Maker Faire.
And interestingly, at Maker Faire, we only had the static ones. We didn't have the animated ones yet. So you go to the website, and it shows a list of top ones. There's a way to vote. You can totally rig the system because you don't have to log in or anything, so you can just up or down vote things. Anyone can. And then it shows some recent ones. And I thought I'd just go through and show some interesting ones. Well, I'll start with this one. So someone named Leo, I don't actually know for certain who. I've heard the speculation it's probably a Leo Wong. Provided this one is certainly not a haiku in terms of its size, but it's not too bad. It produces this interesting symbol, and I was inspired by this to further embellish it, and I took and converted many of the operations that he was doing that were sort of assuming binary operations, and I converted them into sort of the continuous equivalent to get something very pretty there out of it. And there's a further version of it. Let's literally just let the whole thing load up. There's many, many, many of these. And of course, actually, I'm going to want to, well, I'll go back and do that later. But and I later got the notion to animate it, and so then you have this sort of thing. And I'm just sort of warping the coordinate space up there at the top as it goes. And it's really not, I mean, this one is obviously very, very complex. But what's kind of more interesting to me is what you can do with actually a fairly small number of things. This is actually, for some reason, this one was actually one I came up with fairly early on. And it's been sort of my personal favorite. It also doesn't quite fit the constraints of a true Haiku, but it's a very, very small program and produces a very interesting image. There have been some very, let's see, there's all kinds of, let's see, scales breathing here. All kinds of lovely things that you can do with a fairly small set of expressions. There are, okay, let's see, I'm going to do this the right way. There's the electrified larva. Now, an interesting further embellishment that occurred was that Ting actually did another implementation of these haikus on top of his F# fourth implementation, and he of course immediately thought, well, I should do world flags, and so there were a number of flags that he submitted. He had done this before animation had been added, but I figured, let's not just do the flag, but actually animate it and have it flapping in the breeze. And these aren't, they're not too bad. There's a little bit of heft here to get the thing animated. Oh yeah, this is just the original. Yeah. So some of the large ones, let's see. Let's find some actual haikus. Okay, I'm going to actually go back. Now I'm going to show some recent ones that demonstrate the audio. So I had this old implementation where where it was raw audio, and that was just right out. But this is me. So the way the audio is currently done, I'm not wedded to this at the moment, but there's a point here and a point here that control the, this one controls the pitch, and there's, if you can imagine, a 10-note pentatonic flute, and then this is the amplitude, and sort of trips it and perturbs it in interesting ways. And you can do interesting things. Unfortunately, I was not able to get the audio to hook up to the speaker system. It does not.
A regular headphone jack, because I've got speakers.
Oh, did you? Yeah.
Yes. I'll drag the rest of it up. Do you have a spare plug? Good. So far, so good. We're lost. Plug. Oh, there it is. It's an IQ test. Failed. All right. Take it and stick it, so to speak.
And this one's actually, this is a fairly terse one. I think I have a true haiku in here somewhere. Let's see. Let's see. No, that one's not a true haiku. Let's see. Enter. There we go. Oops. Let's do some others. Let's see. Well, anyways, I encourage you all to go to fourthsalon.appspot.com. Depending on your particular browser or whatnot, the animated ones may or may not show. And you could, I should briefly mention that there is of course the editor, and you can submit them. And it looks something like this. So if you put in a small haiku and you hit update, then you get the haiku. Yeah. So, anyways, any questions? Yes.
Next video
While James speaks his way, I'd like to ask.
Do you need this or?